and pray. Father, thank you for this day. Thank you for we have woken up. Thank you for our members who have not yet joined. May you help them to join. Father, I place this lesson into your hands. May you help us understand what we are going to be taught today. In Jesus' name, we pray, amen.
Amen.
Thank you for the prayer. Today we are going to look at what we call tree diagrams, and that's going to be our major area of concentration throughout this lesson. And when you look at my screen, I have showed you a tree diagram. When you look at that tree, what are some of the things what are you observing about that tree? Any features, or how can you describe that tree? Anyone to give us just a hint? How can you describe that tree? Which features? What are you seeing on that tree? Yes, the tree you're seeing on my screen. Good. I've seen some answers in the chat. Okay. Yes, Desire and Samsung.
I'm seeing branches.
Branches. Good. Okay. Yeah, there are branches. That is one. And looking through the chart, people are saying it has leaves, it has a stem, it has branches. Very good. So that is what we are going to be dealing with. So here, when they talk about tree diagram, expect such things, except the leaves, except you will be able to see the branches and other features. And what is our key learning outcome today? So our key learning outcome is that by the end of this lesson, you should be able to use probability trees to determine the probabilities of what we call mutually exclusive and what we call independent events. So yesterday, we looked at mutually exclusive and we looked at independent events. So we are building from what we had yesterday. And when we go on, when you look at my first diagram, I'm showing you that I have a tree. When a tree falls down, you have noticed that this tree, like you have earlier mentioned, that it has the branches. So we are going to be drawing trees that resemble what I have here. This is the tree we know that is growing, but when it falls down, it will look like this. So our trees, we are going to be drawing trees of this nature, whereby these trees are going to have the branches, like these are the different branches for the trees. But for this time round, we shall assume that our trees do not have leaves. So we shall only consider the branches. But like on a tree, it always has the main stem. So this is where we shall have our main stem, and then the rest will fall. So that's what we are going to be looking at today. So let me ask you to write something about tree diagrams. So take note of something down in your book now. Okay, it seems people have finished. Okay, we are going to continue. In case you have not finished, feel free to take a screenshot. Okay, Yesterday evening, I asked you to get some of the materials. So please have a self-check whether you have any of these materials with you. You must have a small piece of paper, at least one paper. You can have a cup. It can be a plastic cup, but as long as it is a cup, or in case it is not a cup, you can get an empty box. Those are small boxes whereby you're going to put something, or a tin, anything of that nature. Then make sure you have a blue pen or any other pen, or you have colors. Yeah, so those are the materials that you must have with you. And we are going to follow the instructions. I don't know whether we have any person on the call who may want to demonstrate for us practically by turning on your video, and then you show us as you are following the procedure. In case you are there and you are free to have your video on, you can raise up your hand, and then I will spotlight you for the rest to be following from you. Okay. So we are going to follow the procedures, the instructions. So do what the instruction tells you. I saw Patricia. I saw Patricia, Esho Patricia. Do you want to have your video on?
Good morning, sir.
Yes, good morning.
No,
Okay,
kind of dark here.
okay, well, okay. So that is the first instruction. That is the first instruction. Yes, I want you to get that piece of paper of yours. Let me also get mine. Have mine here as well. So I want you are going to make 10 small pieces and fold those small pieces into small balls. Yeah, so I'm tearing mine since you can't hear. And then you are going to make 10 small balls. Hope everyone knows how to make those balls, the small ones, or you fold them into small pieces of paper. So we need 10 of them. Okay, when you finish, let me know through the chat that for you have finished making your balls. Of them, 10 of them. I would have showed you mine, but let me first finish. But in other words, you are folding the papers into 10. We want 10. It seems no one has finished. Yeah. We tear the piece and make 10. Those who are just joining in, we are doing the first instruction. We are making the balls. Okay, Samsung has finished. Okay. I'm also still making mine. Okay. Okay, seems now people have finished. Okay, people have finished. Okay, good. Now we go to the second instruction. Those who are still making, please continue. Now use the blue pen or any colored pen to shade 4 balls blue. Leave the remaining 6 balls white. So I want you to just pick on the 10 you have, pick only 4 and put a blue mark on those balls. Yeah. I want us to distinguish them. I want us to distinguish them. Yeah. So get the white ball and then put a blue mark on them. Take an example in case this is my ball that I've made. I'm going to shade it blue. So we need to do 4. To 4 of them, you put a blue mark in case that is the paper you have, in case that is the pen. Then the rest, leave them as white. So I'll expect you. Okay, I'm going to show you here maybe. That is my piece of paper. Yeah. So this is 1, 2, 3, and 4. So have those 4 balls. Then I'm going to have the rest of them, leave them white. So leave a white 1, 2, 3, 4, 5, and 6. When you finish, let me know through the chat whether we're on the same page. It seems people have finished. And now look at the next instruction. At the next instruction, place all the 10 balls into the empty cup. Now, I want you to have your cup. Have your cup. In case it depends on what you have. Those who have cups, put them in the cup. In case you have a cup, put them there. In case you don't have, put them in a small tin. Let me say these are my balls. I'm going to put all of them put all of them inside there. Put all of them inside there, the blue ones, and then the others. So the blue ones, you have about 4 of them. Put them inside your cup. Then also put your white ones there. Put the white ones there in the cup. Are we there? You must follow the instructions. Done, sir. Okay, now we go to the next one. Now the next one, I want you to shake your cup gently such that those balls can mix thoroughly. So I don't know where you have placed yours, but I have placed mine in the cup here. I have some cup here. So I want you to check like the way you are hearing me doing, such that those balls can mix. Something like that. After that, now we are going to go to the next instruction. We are going to the next instruction. Now the first one that we are doing, I want you, don't look through the cup. When you are selecting or when you are randomly choosing a ball from the cup, I don't want you to look there. Don't look there, but I want you to pay attention now. I want you to look at my screen. Now, this is your cup. I want you to pay attention. This is your cup where you have the white ones. Let me assume these ones are my white ones. Okay, where you have the white ones and where you have the blue ones. So assuming that is your cup where you have the white one and then the blue ones. Make sure that they are mixed well. If they are not mixed well, we may not be able to attain what we want. So allow me now to change here. Make sure that you have mixed them very well. Now we are going to choose one ball from the ball and record the color of the ball. So I want you to choose one ball from the cup and then take note of that color. Hope you are finished. Go to the third instruction. Return the ball to the cup and then shake again the cup. I've picked one and I've taken note. And from my observation, from my cup, the first ball that I have picked, according to mine, has been a white ball. That is what I've picked. So I have returned them. Then we are going to the second picking. But one thing I want you to take note, I want you to take note of the sample space, the total number of balls. Now pick the second pick. First check through, like the one I'm doing here, then pick another ball. Randomly, me, I have picked still a white one. For you, take note of what you have picked. Have we finished, members? Have we finished that? Now, make sure you don't look there. I want us to first go back. I want for the first picking members, what was the probability for those who picked white? What was the probability of picking white? You put it in the chat, put your answer in the chat. What was in case you picked blue, for you, now you tell us blue. You can just say white, this was the probability. Blue, this is the probability. What was the probability? Put in the chat, put in the chat. I'm waiting to look at the answers. When you picked, what was the probability that you picked a white? Mugisha is saying 6 out of 10. 4 out of 10. Okay, 6 out of 10, 4 out of 10. Then what of the second picking? That is correct. What of the second picking? What is the probability of blue and what is the probability of white? Timothy is saying 2 out of 5. Okay. 4 out of 10. 4 out of 10. Okay. 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 It seems many of you have picked blue. Yet for me, I was picking white. Okay, we go to the second case. That is scenario 1. Yeah, I'm going. Now, this experiment, we may need to try it about 10 times, but do not mind. We have tried it the first time. We go to the second one. Now, the second one, this is how I want you now. You're going to, you have a simple table whereby this is the total number of balls. This is the total number of balls. Then this is the first picking of your ball. This is the second picking. Now, you tell us how many balls no, I think I need to draw it in another better okay. Allow me to draw it like this. I want you to take note. This is the first picking. This is the second picking. Take note of the total number of balls. Very well. Take the total number of balls. Now pick the first one and pick the first one. Let me put here that this is your tribe. Still make sure that your balls are thoroughly mixed and pick one. Now I have picked a white from my cup. That's what I've got. And how many balls do I have? Before you pick, you first count how many balls you have. So inside I have 10. I have 10 inside before the first picking. So I've picked a white. Now we are going to go back. I'm going to go back. Then the next one, don't return the ball to the cup. So don't put it back. So the ball you have picked, don't put it back. Can I know through the chat now? Members, how many balls are you remaining with in your cup? After the first picking, how many do you have? Shiny is Sabera, they are saying 9. So here, before we go in for our second one, we are going to put 9. Members, we continue. Pick. I'm picking. For me, I've picked a white one. Put here the white one. Continue. Now, this is number 3. Now, still, after picking for this case, we are not putting the ball back. So don't put the ball back. Tell me how many are you remaining with inside? Amy is saying 8. Sylvia is saying 8. So here I'll put 8. Yes. I want you to go back. I want you to go back here. And now put pick. Let me see what I'm picking. This time I've picked a blue. That is the third trial. Okay? We go now to the fourth trial. How many are we remaining with? For me, I'm getting here -7 that are remaining inside. Very good. You pick again. Pick again. So me, I'm picking and I'm picking a white. Okay. Now, we have looked at the first and then the second case. We have looked at two cases. I want you to look at them very well. I want you to look at them very well. Now, let me first ask you to put back all your balls inside, and we do another try on the first case. We do something more on the first case. Yeah, first case. I am going back to the first case. Put back all your balls. This is the total. This is your first picking. This is the second picking. This is the third picking. We are picking again for the case one because we did not take the. So first, how many balls do we have? We have returned all our balls. So how many balls shall we have in our cup? 10. So here we have 10. So pick. So I am picking from the cup. So here, me, I have picked a blue. But here, the instruction for case one, you return the ball inside. So I've put back my ball. So what is the total we have now in our cup, members? Is Chema said 10. Second trial, we have 10. Put it back and then check your cup. So I've picked for the second trial, and I've picked still a white ball. Then after picking, you place it back. Make sure you check your cup such that they can mix well. Go on. Pick again. Remember you have returned, so they are 10. I've picked me. I've picked now a blue. Yeah. Yes. Now, we are coming. I want you to observe those two cases very well because the items that are coming are going to be coming from case one and case two. So we are using case one and case two. So I want to go back here. What have you observed about the two cases? So you raise up your hand and you let us know. Yes, Desire.
I have realized that in the first pick, we are picking with replacement. I mean, without replacement. Then in the last, we are picking with replacement.
Okay, good. That is one observation. Yes, Timothy.
For me, I've observed that in the two cases, first of all, every time you take out a ball, in the second case, the number in the sample space reduces, unlike in case one where when you pick a ball and you return it, the sample space still remains the same.
Okay, good. Yeah. So hope members have heard that one clearly. Yes. So those are the two cases we are going to look out for today in today's lesson. Those two cases is what we are going to be looking at. We are going to look at the first case is we are going to look at case two. And whenever you are attempting items, I want you always to ask yourself, is it case one or case two? Because the question will be telling you that the balls are returned after picking. Now, when they say that the balls are returned after picking, then you know you are dealing with case one. So what do you need to notice? That your total sample space remains the same, doesn't change. So you notice that for our case one, the total remained 10, remained 10, remained 10. It did not change at all. So whenever they tell you that the ball is placed back, the ball is returned, the ball is replaced, then it means that once the ball is returned inside, it means that the sample space does not change. Then, when they tell you that the ball is not returned after picking, then you need to look at the number of balls remaining in your bag, in your cup. You notice that these balls keep on reducing. After picking a ball, you notice that the sample space keeps on reducing. Members, can I know through the chat whether you have got those two concepts, case one and case two? Have you got the difference between the two cases? Okay. Yeah. Now I'm going to ask you to make your own notes the way you have understood those two concepts on the following. I want you to make your own notes on what you write something about with replacement, and without replacement. I want you to write somewhere in your book what you have understood, that when we say the ball is replaced, what have you picked? What about when the ball is not replaced? I want you to take note of those unique features. Mugisa still wants the procedures. Okay. Mm. Mhm. So everyone, you write in your own words, don't mind, for you write how you have understood those two words. Yeah. Chemtai?
Yes, teacher.
Yes, Chemtai, share with us what you have put down.
Teacher, I'm still writing.
No, just tell me what you are writing, okay?
Okay, what I wrote is when the ball is replaced, it's just like picking a ball in a cup or a box and record the color. Yeah.
What about the total? Because I want you to capture something on total. What about the total?
Then repeating the total.
Like the total number of balls, what happens to them?
It does not change.
That is with it?
With the replace.
Now you'd frame your answer very well, such that we can pick something now very well. Frame it again.
Okay. When the ball is replaced, it's just like picking a ball in a cup or a box and record the color, but the total still remains the same.
Okay. Thank you. That is good.
Okay.
Continue. Can we have, okay, I can, for me, let me choose randomly. Anna, Li- Lily, or Anna, any of you? Okay, Gavanian.
Morning, sir.
Yes, good morning.
I think what I've wrote is with the replacement, the total sample space is the same after picking and putting back the ball. But without replacement, the total sample space is not the same after
It's not.
picking the ball and not returning it back.
Okay. Okay, very good. So members, make sure you write the way you have understood them, in your own word. Okay. Okay, now let me display something. Hope Audrey, we are together. This is for me how I wrote mine. This is how I wrote mine. So hope you have harmonized your answers and put the keywords. So one of the keywords I expect you is to include that word that the sample space will, for one, reduces. For the other, the sample space remains the same. Members, are we good to continue? Has everyone at least picked something? Okay, Joyce is saying yes. Okay, I think we are there. Okay, Gavanian, this is tree diagrams. This is tree diagrams. Write our first activity. Write our first activity. Write our first activity. Now, please do not forget, the spaces you are seeing here, what I've left here, is for you to fill in. I've put for you the diagram, so put what you are seeing. Count them and put. Okay, people are asking me to zoom it. I think, okay. According to what people are saying, they are saying 4 blue and 6, eh? Okay. Chamtai, I think I can. 1, 2, 3, 4, 5, 6. For me, for black, I'm seeing 6 of them. So I'll put there 6. So for you, put what you see. Then for the blue, I'm seeing 1, 2, 3, 4. So for the blue, I'm seeing 4. Members, are we finished, right? And we start. Okay. Okay, people are finished. Now, they are telling us that Joy has 4 blue pens and 6 black pens. A pen is taken out of the bag at random. Its card is noted and then not placed. Now I want in the chat to tell me, is this item about with replacement, without replacement? So the answer I want in the chat, it is just tell me with replacement, without replacement. So when you read the question, what does he want? Is it with replacement, without replacement? Very good, very good. Now, all of you have understood very well. Okay, now I am asking again, what is the total sample space? What is the total sample space? Very good. The total sample space is there. Very good, very good. Now I'm going to go to my second slide and I draw my bag. So you're going to, okay, let me use a color. I know I can use a color. I wanted to use this because I know Joy has a maroon bag. So this is my bag. Now in the bag we have, now you are going to let me use that these are the 4 blue pens. Then I'm going to, and they told us he has 6 black. So I'm going to say that let the blue pens be represented by B. Then let the black, we are going to have challenges. We are going to have challenges. You are going to allow me to use different letters. Let the black pens be represented. Kindly let me know which letter can we call the black ones. I don't want us to use the same letters. People are saying K. Okay. Okay, people are saying K. So black is K. So allow me to erase this such that we don't mix them up. So K is what is representing our black. Now, this is our bag, and we have said that the total, or what we call the sample space, is equal to 10. Now, like we have said that this is a tree. So we are going to draw tree with a branch. Now, I'm going to draw the first one. I want us to pay at, now, this is my bag, and I'm going to pick. This is what we are going to call the first picking, the way we have been picking. Now, if you pick, chances are, like we are using those things you have inside, those things you have, the 4 blues you have, So when I pick from my cup, this is what can happen. When you pick the first one. Now, if I happen that this side here, I have picked a blue, not so? Members, through the chat, if I pick the blue, how many blues are going to remain in the bag? Put for me in the chat. How many blues are going to remain? Very good. We are going to remain with 3 blues. Yes. Let me put here 3 blues. What about how many black pens remain in the bag? Joanne has answered. No, now here we have to pay attention. Pay attention again. I repeat, when you picked in your bag the first time, you picked a blue, not so? If you pick a blue, the blues reduced to 3. How many black pens remained in the bag, members? 6. Because you did not pick any. So I'm going to come here and I write that here I remain with 6K. Now I come again. But remember, some of you went on and picked a blue. But some, let me now draw another one. Now imagine another person, for him the first picking, he picked a black. Members, through the chat, how many black balls did we remain with inside our bag? How many black? 5, very good. So here I'm going to come and I put that here. I'll have 5 black. What about the blues? How many blues did we remain with? Blues? Perfect. Perfect. Now, that is where we are starting from. Now, we are going back now to the probabilities, to write the probabilities. The first thing I wanted is for you to understand the picking. Now, when I go back here, I'm going to, because remember here we are not replacing them, You need to know. Now here, the chances that someone picked a blue, remember inside the bag we had a blue. So remember our probability, we always said the number of events out of the number of sample space. Now the events are the blues. Here, this blue. So we had 4. So here our probability will be 4 out of 10. So you are going to allow me to write here 4 out of 10. Whereas for K, inside our bag we had 6 members. What is going to be our probability for that one? Put it in the chat. What the events? I'm saying the answers are coming. Very good. So here we shall have 6 out of 10. Members, are we together up to that step? Are we together? Because that is the very important step now. I'm seeing the answers are there. Yes, people are saying yes. Very good. Now, members, we are going to, this is the first picking. Now we go, remember, this is the first picking. Now, what is the total sample space for our balls here? Remember, you are not returning the bags. So what is the total sample space for your balls that are remaining in the bag? Kafulma is saying 9, 9, people are saying 9. Very good. So here we shall have 9, and also here we shall have 9. Now, members, we are going to pick again. We are going to pick again. Now, when I pick, remember we are not returning our balls. I'm going to pick. I want you to let me know. Remember, we are picking 2 times only, but allow me, for me, I love putting our bags back. Now, chances still when you pick, some of you can be unlucky and you pick a black one. Now I want, I'm going to just choose randomly. Shekaina, unmute.
Yes.
Now, if I have picked a blue one, how many blue pens are we remaining with?
We're going to remain with 2 blue pens.
We are going to remain with 2 blue pens. What about the black one?
6.
6. Okay, thank you. I pick another one. Let me pick a quote Wilka. A quote is not unmuting. Abraham Makai. Abraham is not unmuting. Audrey Mwine. Audrey is not. Okay, Audrey, now tell us. Now, if someone here picked this is a black pen, how many black pens are we going to remain with here?
5 black pens.
5 black pens. Then how many blues do we remain with?
3.
3 blue pens. Thank you. Very good. Members, that is very good. Very good. I'm picking other people. Now we go here to this branch here. Now this branch is coming like this, and this branch is coming like this. Now here, always it is very good practice. The letter you started with here, let it come here. Then the other one can come here, such that here you can maintain your case, like the way you have seen me maintaining my blues. So can I choose someone randomly? Or someone can put up the hand. You can put. Yes, Magez. Yes, tell us. If here we picked a black pen, how many black pens are we remaining with now?
4.
We are remaining with 4 black pens. Then what about the blues?
4.
We are remaining with 4. Very good. That is good. I'm choosing, yes, Gilbert. Gilbert?
Yes.
Gilbert, tell us, if here we picked a blue, how many blues are we remaining with in our bag here?
3.
We are remaining with 3, good. Then how many what?
5.
5.
Yes.
Very good. So members, that is what is very important. Now, the next one is finding our probabilities. Now, I'm going to go to this branch here. I ask myself, initially, our bag had a total of 9. And here I picked a black. So what were the chances? So meaning that the event initially was 3. And the total number of balls within the sample space was 9. So members, do you agree with me that here our sample will be 3 out of 9? Now members, tell me in the chat, what about here for K? What is going to be your probability for K? For K here, this downward branch. Remember, initially they were 6. Very good. 6 out of 9. Hey, Esther, check out Esther. Remember, you count how many balls you have inside. Okay, Esther. Yes. So we continue. Now here, still in this bag here, we had a total of 9. Members, what is the probability of you picking a blue? Put in the chat quickly and we see. Put in the chat and we see. What is the probability? 4 out of 9. Jonah, can you? Jonah. What is? I think it was Jonah. Jonah who's lost. Chicken Jonah. Is it you that is lost?
Yes, sir.
Yes, Jonah, tell us. Where?
Master, I've just joined.
Oh. Now, Jonah, that is where the challenge is. But maybe keep on. I will try to explain on the next number.
Okay.
Yes, Linda?
Good morning, sir.
Morning.
Sir, why is it that we are having 9 volts?
Linda, have you done the other experiment that we are doing?
No, master.
Hey,
You just
meaning
came
you.
a bit late, but I'm trying to pick up.
Oh, now that's where. Yes, like we have said that why the 9? Because is that here we are picking and not replacing. The moment you pick the ball, you don't place it back in your bag. You remove it completely. So meaning that the balls are going to keep on reducing. So that's why you are seeing that there is a reduction in the total sample space.
Yes, sir. Thank you.
So here, members, we shall have 4 out of 9. And here, we shall have 5 out of 9. Now, this is what we call the second picking. Now, members, sometimes they can tell you even to pick 3 times. Even 4 times, it is very, very possible. But since here they have told us 2 times, allow me to stop at only 2 because they told you 2 pens. So picking 2 pens, meaning that you picked one and you picked another one. So those are 2 times. So this is where we end for the 2 times. But I want you to take note. Always you mark yourself for these numbers of probability. You can mark yourself and say that maybe things have moved on well or things have not moved on as expected. So one way to mark yourself, one, I want you always to look at the total at each branch. Whenever you are dealing with a branch, you make sure that at that branch, when you add, you get a 1. That is the first thing you need to take note of. That when any branch you are forming, this is one of our branches, that when I add the total probabilities, 4 out of 10 plus 6 out of 10, the answer I get should always be a 1. The same for any branch that you form, even here, when I have 3 out of 9 plus 6 out of 9, the answer I get should be a 1. Even here, when I add 4 out of 9 plus 5 out of 9, the answer I get should be a 1. So that is one way to know whether what you are doing on a probability tree diagram is correct or wrong. The moment you add up those probabilities at any branch and you don't get your answer as a 1, then it is an indicator that there is something you are not doing right. So you go back and then review your work. Hope that is very, very fine. Now, after doing this, you are noticing. Now, I want to take you back to what we covered yesterday about what we called independent and what we call independent events. We say that independent events, the one like independent, when you pick one, doesn't affect the other. So this is one of the examples that you're picking does not affect the other. Now, what is going to happen here? We are going to go back and answer our question. Our question told us that draw a tree diagram to show the possible and the probabilities for the first 2 pens removed for the bag. That one we have done. Then the second one, calculate the probability that the first 2 pens are black. Now I'm going to come here at my branch. Now allow me to write for you here. When you look at this branch, the way it is moving like this. Here you picked a black, and here you picked, B is a blue. So here it means that along this branch, you have probability of blue, blue. Then I come here. For this branch, I have picked a blue, I have picked a black. So here you have probability of blue, black. When I come to this branch, I picked K and then a blue. So at this branch is where you have your K and then the B. Then at this branch, you have K and you have K. So here I have K and K. Now, you ask yourself, what does the question want? The question was telling us that they want the first 2 pens are black. And according to our thing, we represented it. I want you to tell me in the chat which probability are we going to be taking. Choose on the 4 I've written down. Which probability do you think they want? Which probability do you think they want? Joan is saying KK, Shekaina is saying KK. Very good. So they want us to find probability of K and K. Very good. So I'm going to come here and I say probability of K and K. This one, now I want you to know, whenever it comes to the branches, since we have said they're independent, KK means that we shall have the probability of the first K times the probability of the second K. Remember what we talked about independent events. So for the first K, our probability was 6 out of 10 times the second probability of K, which is 5 out of 9. You can notice this was 6 out of 10, this was 5 out of 9. Then I'll go on and now multiply. When it reaches multiplication, remember when you are multiplying now like such, you multiply these numerators. So you say 6 times 5 out of the 10 times 9. Then you go on and say, what is my 6 times 5? That my 6 times 5 will give me a 30. And then what is 10 times 9? Then this one will give you a 90. Then feel free to reduce it. That 30 divided by 90, I end up with 1 out of 3. Members, let me know whether we are together on that point. Very good, Favor. Okay, yeah. So let's write. Let's put something down. Yes, Jenna.
Good morning, teacher.
Good morning.
As for me, I just have question. one time I attempted a number that was talking about an umbrella and a bottle. And I drew my probability tree diagram very well. And they asked for a probability of picking a bottle and an umbrella. Then, for me, I followed the branch that give me a bottle and an umbrella only. And there is my fellow student who followed a branch of a bottle and an umbrella, and another branch of an umbrella and a bottle. So, master, we keep on arguing with that student.
Okay. Jonah,
Yes, sir.
you tell me. When I put in the bag,
Yes,
in a black pen and a red, this is my black pen.
yes,
And I put, this is my bag. There is a red pen and there is a black pen. So when someone tells you, when someone asks you, which two colors do you have in the bag? When someone answers a black and a red, and another one answers red and black, who's wrong, who's right?
I think both of them are right.
Both of them are right.
Yeah.
Yes. So now for your case, all of you are right, but you have to go on when, like in probabilities, when I say a black or red, something like that, like we looked at all. So black and red, red and black. So these are the same things. The only difference is that the first person who picked a black. Then the second part, this person who picked a red. So, but in English, when we say black and red, it is the same thing like saying red and black in English. So that one, that is just the English thing. So when someone asks you black and red, then it means that you have to add black and red plus red and black.
Okay.
So you have to add. Yes?
I had thought that when they say black and red, you follow only that branch.
Oh, not really, not really. Like in
Example,
probability, order
yeah.
doesn't matter.
Okay.
Order doesn't matter. So you add both of them. Okay.
Thank you.
Okay. So let me hope people have finished. Members, are we good to continue? But let me answer this question. Gift.
Good morning.
Yes, good morning.
Yes. I'm just asking that if the people picking are three, do you do like 3 branches or still two?
When you, like here, when they tell you to pick 3 pens,
No, the other people having to pick a 3.
Oh, okay. We are going to look at that scenario.
Okay.
Okay, yes, but you draw 3 branches. Okay. Members, I want you to take note of this. Hannah Msime, hope we are on the same page. And Patricia, Herbert, hope we are on the same page. Yes, Hannah? Okay. Hope also Lily. Okay. So the sum of the probabilities of the branches is always equal to 1. Okay.
this one.
Yeah. Hope we have finished. Okay, we write the second question. So fill in those spaces basing on what you are seeing on the screen. It seems people have finished. Okay. Now they are telling us, I don't know how many blue and red you have seen. I don't know how many you have seen. I don't want to count offside. I don't know how many you have counted. Okay, people are saying 6 red and red 6 for blues. Okay, the blues there, people are saying there are 4 and the red are 6. Okay, they are telling us 2 pens are drawn in succession at random from the box with the lip placement. With the lip placement, it means that we are going to put back our balls every after a pick. Whenever you draw a pen from the box, you put it back. So we start on our question. So in our question, I'm going to come. This is my bag. And in my bag, we have 6 red and 4 blue. So these are 6 red and I have 4 blues. Now we are going to pick, but in the chat, let me know what is the total sample space that you have. What is the total sample space that you have? Okay, the total sample space, people are saying 10. Very good. So here, allow me that the first pick here, this side, we are picking a red. Members, let me know through the chat, how many red balls shall we remain with in this second bag? This is our bag after the first pick. After the first pick, how many do we have? People are saying 5. 5. And now, I want you to remember, you get back your cup, this cup of yours. This cup of yours. Pick out one ball. Remember, the question has told us that we are replacing them. Put back your ball. How many do you have now? I don't know that members are picking it. This question is with replacement. So how many do we have? I want you to go back. Pick after, put it back. So how many shall we have? 6. Very good. So here we shall remain with 6 red. Then what about the black? Sorry, the blue. How many blues do we have now in that bag? I'm looking through the chat. People are saying 4. So here we shall have 4 blues. Please take note of that. And here our total is going to remain 10. Hope members, we're on the same page. Now we go back this side where we have the blues. If the first time you picked a blue, how many blues do you have inside the bag again now? How many blues do you have? People are saying we have 4. Then how many red? What about the red? What about the red? People say the red are 6. Very good. Okay, now can we go on? Members, let me know. For this first branch where we have the red, what is the probability of picking a red from the bag? Write it through the chat. What is the probability of picking a red from the bag? 6 out of 10. Very good. So here we shall have 6 out of 10. And members, you agree here we shall have 4 out of 10. Those who don't know, remember we have said that our total sample space has 10 pens. But the number of events that the pen is red, according to this branch, is that there are 6. So the chance of picking a red pen is going to be 6 out of 10. Okay. Desire, I'm seeing your hand up.
So I was requesting for the previous slide of the question.
Oh, okay. I'm going to take back after. Is that okay? Okay. Now I'm going to pick the second time. This is our branch. We are picking. So I want 4 people who are going to be picking for us. You raise up your hand and then you pick for us. Four people. Just raise up your hand. You're going to pick up for us and tell us what to write. Okay, I pick Chemtai. You're one. Okay, yes, Hannah. Anna, let me start from here. Anna, this is the red one. You tell us what we have.
I think because we are picking and picking that.
Anna, can you get a bit close to the microphone? You are saying?
Can you hear me now?
Yes, clear?
Okay, so I'm saying that since we are picking and putting back, it will remain 6 again.
To remain what? How many balls shall we have here?
6 red.
6 red. Then the blues?
4.
4 blues. What's going to be our probability here at this branch?
It will stay 6 out of 10.
6 out of 10. Thank you, Hannah. I go to Christian R. Here. How many balls do we have?
6R.
6R. Then the blues?
4.
4 blues. What is going to be our probability at this branch?
4 out of 10.
4 out of 10. Okay, thank you. Gavanian. Gavanian. Okay.
It is gone. Teacher.
Here.
Therefore, red is going to remain 6 red.
6 red. And then the blues?
4.
4 blues. What is the probability at this branch?
It is 6 out of 10.
6 out of 10. Okay. Thank you. Linda?
It's 6.
Lynn?
6R.
6R. Then the blues?
4B.
4. Then what's the probability?
4 out of 10.
4 out of 10. Okay, good. So that's how we attempt this number. So that is so this is what we call your first pick, and this is the second pick. Now, what is going to happen? They have asked us the first question. Find the probability of picking pens of the same color. Now, when they tell us pens of the same color, Roman 1, probability of same color. Now, members, can you tell me in the chat, what are those probabilities of the same color? Can you put them in the chat and we see what you think of the same color? I mean that the first pen you picked was the same color with the other one. Remember here we said that here in summary, this is going to be probability of RR. This one is going to be probability of RB. This is going to be probability of BR. This one is going to be probability of B and B. So same color, which probabilities are we looking for? RR and BB. Very good. So here we shall say probability of RR plus probability of B and B. So since we have said that these are independent, I'll look for RR. R is up, so it is 6 out of 10 times 6 out of 10 plus BB, which is 4 out of 10 times 4 out of 10. So 6 times 6, that is 36 out of 100 plus 4 times 4, which is 16 out of 100. Then what do I do next? I will add 36 plus 16 and I will end up with 52 out of 100. In case it can be reduced, you go on and reduce it. So when I reduce, I'll have 13 out of 25. That is our Roman 1. Members, is that fine? Is that fine? Let me hope. That is very okay. Okay, it seems we're on the same page. Okay, then I go back to the second question. Second question wanted exactly 1 red pen. So exactly 1 red pen. Members, can you put in the chat which probabilities are they interested in? Exactly 1 red pen. So members in the chat, put which probabilities are we going to look for? Red, blue, blue, red, and red, blue. Very good. So exact 1 red. So meaning we have red, blue plus probability of blue and red. Those are the probabilities we look out for. Very good. So red, blue, according to what I have here, it will be 6 out of 10 times 4 out of 10, then plus blue, red, which is 4 out of 10 times 6 out of 10. Then when I come here, I'll say 6 times 4, which will give me 24 out of 100 plus 24 out of 100. So 24 plus 24, it will give us our 48. So it will be 48 out of 100. And 48 divided by 100, when you reduce, you'll get your answers 12 out of 25. Members, can we first write that? Let's first write before we continue. Okay. Linda?
But are you getting 100? Yet it's 100 plus 100 making 200.
How are you getting 100? You first, Linda.
Yes, sir.
Yes, Linda. You first, when you have 2 out of 4 plus 3 out of 4, what is your answer?
That's 5 out of 8.
5 out of 8. Sure? Okay,
So we are not
okay, Linda, we start from here. What is the LCM of 4 and 4?
okay, so now I'm going to use the LCM course.
The LCM is
16.
16, really?
4.
Remember, for LCM, you go and say, we have two numbers, 4 and 4. So by 4, 1, 1.
1.
So what is your LCM?
4.
4. Then you say 4 divided by 4, you get?
1.
Times 2?
8.
1 times 2?
2.
Now, okay, what we are going to do, Linda, what we can do, you get your calculator. Do you have a calc?
Yes, sir.
Now get your calc. Get your calc. Do you have you got it? Now in your calc, I want you to look for me. Look for AB, where there is AB/C. Are you seeing that?
Yes, sir.
Now we are going to place this fraction inside. So you say 2, place that AB and put 4. Finished?
I'm done.
Then say plus 3, put this thing AB, then 4.
Yes, sir. Place that it's giving me something like 1 comma, 1 comma, then
1 comma, 1 comma and
4.
And 4. Eh? Now you place that A, B, and C again.
I'm done.
What does it give you?
That's the same.
1, it is giving you 1, 1. So now this one means 1 whole number, 1 out of 4. Is that fine?
Yes.
Yes, but when you place that ABC again, when your answer is there, it's going to give you something. So that is the answer, which is the same as 5 out of 4. Now here you put it on your calculator. You put for me 20, you put 24, put that ABC out of 100 plus 24 out of that thing out of 100 and tell me what you get.
I'm getting 12 out of 24.
Isn't that the answer we have?
Yes, sir.
Yes. So whenever you find that the denominators, Linda, whenever the denominators, these ones here are the same, you only add what you have up. Then you write down what you have.
So what if it's subtracting? Again, we find the LCM.
If it is subtracting, let me say, as long as the denominators are the same, these ones here down are the same numbers, you also just subtract 3 minus 1, 2 out of 4.
Okay.
Is that fine?
Yeah, it's fine.
But now start utilizing the calculator the way I've showed you whenever you meet those fractions.
Okay.
Okay. Okay, members, we can continue to the next part. They wanted at least 1 red pen. So we said earlier this week that when they tell us at least 1 red, probability of at least 1 red. So we said at least 1 red means greater than or equal to 1. So meaning I'll expect to have red, blue, plus probability of blue, red, plus probability of red and red. So red and blue, according to our red and blue, is 610 for 10. So here we shall have 610 times 410 plus this is 410 times 610 plus then red. When you check red, you notice that red is 6. So here we shall have 6 out of 10 times 6 out of 10. So 6 times 4, you will end up with your 24. Then 4 times 6, still it is 24. So I'll have 24 out of 100 plus 24 out of 100, then plus 36 out of 100. So Linda, let me now get Linda again. Linda? Linda?
Yes, sir.
Tell me what we are going to do here now.
We are going to use a calculator.
Okay. Use your calculator and tell me the answer.
So it's giving me 21 out of 25.
21 out of 25. Good. So that is the answer. Okay. So members, those who want, you can first have 84 out of 100. And when you reduce, you get 21 out of 25. Okay. Okay. Okay, then the last one, the last part, wanted at most one blue pen. And when we say at most means less than or equal to. And you should now, at the word at most and at least, please, at most one blue pen. Please start start having those words with you, because they are going to be very common in the next two topics we are going to be doing. That is in linear programming and in equations and inequalities. So at most one means less than or equal to one. So when they say at most one blue pen, it means that you may have no blue pen at all. At most one, so it means you can have 0 blue pen or just one blue pen. So here, members, what probabilities do you think they want us to get? Put for me in the chat. What probabilities do you think they want to get? Put in the chat. Gift, we have said at most one blue pen. At most, what we have said at most. Yes. At most. At most means less than or equal to 1. And when they tell you, give me the numbers that are less than or equal to 1, meaning that I can give 0, I can give 1, even I can give the negatives. So here I expect you to have anything. It can have 0 means that it has no, that you can pick and you don't pick any blue pen. So human, that is correct. So let me ask you now to go on. So 0 means that you have picked, but you didn't pick any blue pen. 1 means that you picked, but you picked the blue pen and maybe a red and a blue. Yes. So Debbie, I repeat Samsung also. I've said when they say at most 1, at most means less than or equal to 1. Catherine, I'm repeating again. Please and please, when we say less than or equal to 1, it means it can be a 1 pen, it can be a 0 pen. So when we say 0 pen means that you have picked, but you have not picked any blue pen. Instead, you picked other pens. Yes? But here we cannot have negatives in probabilities because we said probabilities is between 0 and 1. So, and we say that 0 means that you are unlucky. It is you are uncertain. Yes. So I expect you to have 3 things. Mixed on, that is okay. You can either have a red, blue, blue, red, or red, red, and you didn't pick any blue, blue. That is the meaning. That is the meaning. Okay. So you find your answer. Find your answer. I want to do one for 3, and then I want to do one which has 3 branches, I think. But that one I can show you probably, and then I give you a number to try out. Okay, let me hope. Caroline, I repeat, I've said for at least 1 means 0 or 1. Means you can pick a red and blue, you can pick a blue and red, or you can pick a red and red. Those are the only ones you can pick. Members, are we on the same page? Let me know. Let me know whether we are good to continue. Okay. So I'm going to demonstrate when we have 3. But after demonstrating, I'll give you a number. Yeah. Now, when I have 3, someone asked about 3. Let me say I have 2 black. I have 3. No, let me use coins. Okay. Let me first use this. 3 red. Maybe I have 2 green. So members, the total number of balls we have is what? Put for me in the chat quickly. What is the total number? 7. Okay. So here we have 7. So when we are having 3 branches, this is 1, 2, and 3. So here, when you pick, depending on the picking, let me say without replacement. So this can be a blue. This one is going to be my red. This one is going to be my green. So if it is without replacement, so if I pick a blue, members, how many blues shall we remain with in our bag? If I pick a blue without replacing them back, we are not replacing. How many blues shall we remain with? Very good. We shall remain with 1 blue. So here I will have 1 blue. Then the rest, since we have not picked them, we shall have 3 red and 2 green. When here I pick a red, it means my blues will remain 2. I remain with the 2 red, and then I remain with the 2 green. When I pick from this side, I remain with my 2 blues, 3 red, and then 1 green. So here my probability of picking blue will be 2 out of 7. Here it's going to be 3 out of 7. And here it is going to be 2 out of 7. Then you pick again 1, 2, 3. 1, 2, 3. 1, 2, 3. Members, is that picking for 3 clear? Have you understood how you're going to pick when there are 3 balls? Okay, Shine has said yes. Okay, yeah. Allow me now to give you a number. Okay, now allow me to give you a number. So let's write it. This is going to be our what? Our exercise. Yes, Gavanian, unmute.
Excuse me, Master.
Yes.
On Roman 1,
Mm.
here they asked for at least 1 red, yeah?
Mm.
Now, why did you add the blue pens when they asked for only red pens?
They said at least 1 red. Not so? At least means what? Means greater than or equal to 1. Remember here when you are picking 2 times, not so? So when you pick a red and a blue, do you have a red pen with you here?
Yes.
Yes. When you pick a blue and red, do you have a red pen with you here?
Yes.
When you have a red and a red, do you have a red pen with you here?
Yes.
So at least means it can be either 1 or more than that. That is the meaning.
Okay, Master.
So when you tell your parent that, Mommy, this term I need at least pocket money of 10,000, it means that the minimum she has to give you is 10. Then the rest, then but she can give even 30,000, 40, and so on. But do not command them on what to give you. Always just request what they can give you, what they can afford.
24 plus 24.
A bag contains 4 Hope my handwriting is clear. Yes, it's not so clear. Then I'll improve it. Okay. Yes, gift. Yes, gift. Gift.
So, teacher, in some scenarios, you can have, okay, they give you 2 items and then there are 3 people to pick. So how do
Yeah.
you?
Yeah, even if they are free, gift, even if they are free, for you don't worry. Pick the same way we have been picking. Even if they are free, you go on and pick. You go on and pick the way we have been picking.
Like when the items are 2.
Yeah, even if the items are 2, that's what I'm saying. That even when the items are 2, let me say this is, okay, let me use a coin. Here you'll pick a head and you'll pick a tail. So probability of picking a head is a half, probability of picking a tail is a half. When I pick again, I can either pick a head or tail. So still this is a half, this is a half. Still even here, this will be a head and a tail. So this will be a half and this will be a half. When I continue at this branch, I can have a head, I can have a tail. When I continue here, I can have a head and a tail. When I continue here, I can have a head and a tail. I can have a tail and a head. I don't know that is okay, gift.
It's okay, but when there are 2 things and then the people are 3.
Yes.
Like, for example, you're having a black pen and then you're having black pens and blue pens, and then the people are 3 to pick.
No, they are not 3 people. Like it is 3, like you are picking 3 times. Because if the people that are picking are 3, it means that it depends on how many times are they picking. Are they picking in the same bag? Or
in the same bag, but in 2 rounds.
In 2 rounds. Then that one is also possible. Yes. So still you can draw a table. You show, but now that one can be at least. Okay, you will send a question. Just send a question, then we can do it.
Should I send it now?
You can send it on WhatsApp, then I'll pick it when we are doing more scenario items.
Okay. Thank you.
Then the last question. Hope people have finished. You can take a screenshot. I want to put the last number. I want to put the last. Hope people have finished. You can take a screenshot. Okay, hope members have finished. I'm going to continue. I want to put the last number. The last number. Okay, so you're going to try out those numbers in your free time. You're going to try out those numbers in your free time. So let me hope members have finished to write. Though I've noticed. Yes, Abraham.
So I had a question about the part of at least one. You said that we can select from the part of RB or BR. So you choose one of the probabilities, then you work out that one.
No, you take all.
You add both of them.
Yeah, all. As when they say at least maybe one, let me say one head, or a bit of at least one head. Here I will take as long as there is one or more heads. So this branch here has 3. I will take it. This same branch here has head, head, tail. So I will get head, head, tail, head, 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 at least one head. Head, tail, head, head, tail, 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 head, head, tail, head. As long as it has the head, you take it. And then you add those individual probabilities.
Okay.
Okay. Okay. Okay. One more question. Joan and Bintege.
Some question is the difference between maybe if they ask picking either a blue pen or a green pen, then picking a blue pen and a green pen.
Yeah, we say that when you see the word either means union. Yeah, either means union, but allow me to talk about this tomorrow when we are talking about Venn diagrams. Yeah, I'll bring it out in Venn diagrams where they use either. But here the common one they can use is and, a blue and a red pen. But in case it is all, it means union. When they say blue or red, you have said what? I don't even remember. So either something like that. Yeah. But I'll talk about it tomorrow when we are in Venn diagrams.
Excuse me, teacher.
Yes.
Excuse me, teacher.
Yes, please.
Teacher, I still have a problem with at most and at least, something like that.
Okay. I repeat the last. I've said, when I tell you at least 10,000, at least 10,000, it means that the amount you are going to give me, the smallest amount you can give me is 10,000. But you are free to give me,
Yes.
It is the minimum. So I can give you 10,000 or anything above 10,000, but not something below 10,000. When I say at most 10,000, when your parent tells you, I'm going to give you at most 10,000 for your pocket money, it means that the
They are
maximum
giving you 10,000 or below.
Yes.
10,000 is the highest. 10,000 is the highest.
Exactly.
Okay, teacher. Thank you, teacher.
Okay. Friends, allow me that we end here. Thank you so much. I'll respond to the rest of the questions later on. I'm running late for another session. Thank you so much for attending. Have a lovely day. See you tomorrow.